Welcome back to Astronomy Daily, the podcast that brings the cosmos down to Earth. I'm your host, Avery.
And I'm Anna. It's great to be with you. We've got a packed show today, Avery. We'll be looking at a dazzling cosmic light show on a rogue planet, celebrating a decade of discovery for India's first space observatory, checking out some new plasma engines that could get us to Mars in record time, and finally, we'll tell you how you can join a massive global event to celebrate our very own moon.
That's a lot to cover, so let's get right to it. First up, a truly fascinating discovery from the James Webb Space Telescope. It seems it spotted an unusual weather forecast on a world far beyond our solar system, complete with brilliant aurora-like displays.
That's right. Astronomers at Trinity College Dublin have been investigating the atmosphere of a nearby free-floating planet, also known as a rogue planet. This one is called Simp 0136. For our listeners, a rogue planet is one that doesn't orbit a star. It just drifts through interstellar space on its own.
And using Webb's incredibly sensitive instruments, the research team was able to measure tiny variations in the planet's brightness as it spins. These subtle shifts gave them a wealth of information about its temperature, cloud cover, and chemical makeup. But the really unexpected part was the discovery of intense auroral activity.
And what's so strange about that is how these auroras are generated. Here on Earth, auroras are powered by the solar wind, but a rogue planet has no star. So the energy must be coming from somewhere else. Scientists speculate it could be generated by an unseen moon orbiting the planet, whose gravity stirs up electrical currents. It's a real cosmic mystery. It's an amazing find. These shimmering light shows are similar to our own northern lights, but probably closer in strength to the massive auroras we see on Jupiter. And they seem to be playing a significant role in heating the planet's upper atmosphere. The lead author of the research, Dr. Evert Nasidkin, highlighted just how precise these measurements were.
He said these are some of the most precise atmospheric measurements of any extrasolar object to date. And he made a pretty striking comparison, saying at over 1,500 degrees Celsius, Simp 136 makes this summer's heat wave look mild. The team could record temperature changes smaller than 5 degrees Celsius.
And those temperature changes were linked to shifts in the planet's chemical composition, which suggests the presence of huge storms, similar to Jupiter's Great Red Spot, rotating into and out of view. But there was another surprise. Researchers expected to see the cloud coverage change, like watching patches of clouds pass by here on Earth.
Instead, they found that the cloud coverage was constant. And these aren't your typical water-ice clouds. At the extreme temperatures on Simp 136, the clouds are made of silicate grains. Basically, it has clouds of sand. So you've got a rogue planet with auroras, sand clouds, and storms bigger than anything on Earth. The universe is a wild place.
It certainly is. And speaking of incredible instruments peering into the universe, our next story celebrates a major milestone for an observatory that has been doing just that for a full decade. India's first dedicated space astronomy observatory, Astrosat, has just completed 10 years of operations.
That's a huge achievement. It was launched back on September 28, 2015, with a designed mission life of just 5 years. So it's doubled its expected service time and is still providing valuable data. That's a testament to some fantastic engineering.
Absolutely. The Indian Space Research Organization, or ISRO, commemorated the milestone, highlighting Astrosat's groundbreaking insights across the electromagnetic spectrum. It has studied everything from black holes and neutron stars to our nearest stellar neighbor, Proxima Centauri.
And it even made the first ever detection of far ultraviolet photons from galaxies an incredible 9.3 billion light years away. That's a huge distance, looking deep into the history of the universe.
What makes Astrosat so powerful is its multi-wavelength capability. It was designed to observe the universe simultaneously in the visible, ultraviolet, and both low and high energy X-ray regions. This is possible because it carries 5 distinct scientific payloads.
Those are the Ultraviolet Imaging Telescope, the Large Area X-ray Proportional Counter, the Cadmium Zinc Telluride Imager, the Soft X-ray Telescope, and the Scanning Sky Monitor. Each one gives a different view of the cosmos. Congratulations to ISRO and the whole Astrosat team on a successful decade.
Well said. Now, from looking deep into space to developing new ways to travel through it, our next story comes from Russia, where engineers have showcased new plasma engines designed for deep space exploration.
That's right. Russia's Kaldish Research Center demonstrated the new engine at the Army 2025 International Military Technical Forum. This isn't like a traditional chemical rocket. It's a type of ion thruster known as a Hall effect thruster.
Exactly. Instead of using heat and pressure from burning fuel, a Hall effect thruster uses an electric field to accelerate a propellant, in this case, a plasma. The new design is an improvement on an existing thruster, but it uses a system of permanent magnets to apply the magnetic field.
According to reports, this significantly improves the engine's characteristics, including its efficiency, and also reduces its weight, and less weight is always a huge win in spaceflight.
These plasma engines are perfect for maneuvering in orbit and for long interplanetary flights. They're characterized by very low thrust, so you're not getting a dramatic, powerful launch, but they can operate for a very long time, allowing a spacecraft to gradually build up to incredibly high velocities.
It's the tortoise and the hare of space travel. And Anna, this is the really mind-blowing claim. Last year, the director of the Kaldish Center, Vladimir Koshlikov, said that plasma engines will make it possible to fly to Mars in just a month and a half.
That would be a complete game changer. Current missions take 6 to 9 months to get to Mars. Reducing that travel time so dramatically would solve so many problems, from astronaut radiation exposure to mission logistics. It's a very exciting development to watch.
Indeed. And from those future trips to Mars, let's bring it back a little closer to home for our final story. We're talking about our very own moon, and an invitation for all of our listeners to join a global celebration.
That's right. This Saturday, October 4th, is NASA's International Observe the Moon Night. It's an annual event that offers everyone a chance to celebrate the inspiring bond between the Earth and the Moon. And this year, it ties in beautifully with the excitement building for NASA's Artemis II mission.
Artemis II is scheduled to launch in early 2026, and it will send 4 astronauts on a flight past the moon and back, the first crewed mission to the lunar vicinity in over 50 years. So this Saturday is a great time to get reacquainted with our celestial neighbor.
On Saturday night, the moon will be in a waxing gibbous phase, which means most of its face will be lit up by the sun. It's a perfect phase for viewing. With just your unaided eye, you'll be able to see the large dark patches on the moon. These are called maria, which is Latin for seas. Ancient astronomers thought they were seas of water, but we now know they are vast, flat plains of solidified ancient lava that erupted billions of years ago. If you have binoculars or a telescope, you can see even more geological features like craters, volcanic domes, and even bright swirls on the surface. NASA has even provided an interactive map on their website, specifically for the moon's phase on October 4th, highlighting interesting areas and offering viewing tips. There are so many ways to participate, from backyard viewing parties to lunar art projects.
And it's a truly global event. In 2024, an estimated 1.3 million people from 127 countries took part. So if you look up at the moon on Saturday night, know that millions of people around the world are looking up with you. I'll put a link in the show notes so you can find out more and sign up if you wish to take part in this global celebration.
And that brings us to the end of our show. We've journeyed from a rogue planet with sand clouds to celebrating a decade of Astrosat, from futuristic plasma engines to a worldwide party for our own moon.
Thanks so much for joining us on Astronomy Daily. Be sure to subscribe wherever you get your podcasts so you never miss an episode. You can also find us on social media to continue the conversation. Just search for Astro Daily Pod on all the main platforms.
Until next time, keep looking up. I'm Anna.
And I'm Avery. Clear skies.